Hello everyone, welcome to the second Ashbourne Maths video on trigonometry. Here we go. Today we're going to learn a little bit about a technique called RAMS, R-A-M-S, which stands for range, angle, more, question mark, and solutions. Okay, now this spells out RAMS, and this is a little technique that we're going to use in order to solve trigonometric equations like the one that you see on the board, which contain something other than just theta. So in this case, we've got sine of 3 theta. So it just makes things a little bit more complicated. Okay, so let's kick on with this example. So I've got sine of 3 theta minus root 3 cos of 3 theta equals 0. Okay, now, again, hopefully you remember, but we've got two different types of trigonometric function here, okay? So we need to use something clever in order to combine them, because we can't solve something with two different types of trigonometric functioning. Now, neither of these, this is not sine squared, okay? So neither of these are squared, so we can't use our sine squared, cos squared equals 1 identity. So we're going to have to use sine over cos equals tan, aren't we? That's the one we're going to have to use here. So let's see how that plays out. Firstly, take the root 3 cos 3 theta to the other side. So I get sine 3 theta equals root 3 cos 3 theta. I divide both sides by cos 3 theta. And then I notice that my left-hand side, this thing here, is just the same as tan 3 theta, right? Because of my identity. Brilliant. And so now I've arrived at something I definitely know that I can solve. Great. So that's the first rearrangement. That's probably often the toughest bit. So now let's think about how do we go about doing this using our RAMS method. Okay, here we go. So R stands for range. We need to start by getting the range exactly correct. So this question has asked us for a range of of theta between 0 and pi. Now, this means, okay, so 0, pi is a different unit of angle, okay? So you're used to degrees, pi is in radians, but don't worry about that too much now. Pi just means 180 degrees, okay? So this is our range, but do you notice the thing that is problematic here is that these two do not match up, okay? The thing that is inside our trigonometric function is not the same as the thing that is in our range, and we need them to be the same. So we're going to change our range, okay? And what we're going to do is we're going to try and make the theta become 3 theta. And to do that, we're just going to times everything by 3. So it was just the rules of inequalities. We can just times everything by 3. So 0 times 3 is just 0. Theta times 3 is 3 theta. And 180 times 3 happens to be 540 degrees. Now we have our range, which contains the correct thing in the middle. Brilliant. So that's R for range. Now, next, angle. To find angle, we're just going to find our first solution, okay? So 3 theta is going to be the inverse tan of root 3. And hopefully you also know that that is 60 degrees. Again, that's a piece of knowledge that you just need to know. Okay, so that's our first angle. Now, this is the really important bit. You might be tempted to say, well, 60 degrees, 3 theta equals 60 degrees, 3 theta equals 60 degrees, so theta equals 20 degrees, and now I can kind of do my normal tan stuff, you know, plus or minus 180. Do not do that. Do not do that. The important thing you've got to understand is as soon as you do the inverse trig of something to get an angle, as soon as you do that, as soon as you unlock an angle, we need to, at that point, find all the other options, okay? So none of this kind of solving, dividing by 3 or whatever, do not do that. We need to find the other angles now, okay? So let me get rid of that before it tempts us. Okay, so M stands for more. Are there more angles? Okay, and now for this, we need to just remember our rules for tan, don't we? That was in the previous video. So for tan, to find our first angle, we do the calculation. We've done that. Great. Tick. To find our second, third, fourth, fifth, to find all the other angles, all we do is take that first one and subtract or add 180. So we're going to find, so it's going to be 60 degrees plus 180. So this equals 240 degrees. And then we add another 180, and this gives us 420 degrees. And then we can add another 180, this gives us 600 degrees. Now, at this point, we go back to our range. Remember, we're dealing with 3 theta here, and it needs to be between 0 and 540. So that means that 600 degrees is too big, okay? It's outside of the range. So we've got our angles 2 and our angles 3 here, haven't we? We've got angle 2 and angle 3. And so we found our extra angles. And now, finally, we can come to the S of RAMS, which stands for solutions. Okay, solutions. What do we do? Well, we know that 3 theta equals all of those 3 solutions that we had, 60, 240, and 420. Okay, so all we do now is just divide it by 3. So we know that theta equals 20 degrees, it's going to be 80 degrees, or 420 divided by 3, which is 140 degrees. And I've finished. Those are my 3 angles. And that's it. Okay, we're going to very quickly rush through another example. This is example number 2. This time, we've got a slightly more complicated thing going on. We've got sine of 2 theta minus 30 degrees, all in the bracket, plus 1 equals 0.4. Now, our first step is to take the constant plus 1 over to the other side. That's easy to deal with. So I have sine of 2 theta minus 30 equals, and this is just going to become minus 0.6. Okay, and I'm ready to solve that, aren't I? So let's go through our method again. So RAMS, the first one is range. Okay, now this question has asked for theta between 0 and 180. So I want here to have exactly the same thing as inside this sine function. Okay, so I want this to be 2 theta minus 30. So the first thing I'm going to do is I'm going to times everything by 2. So I get 2 theta between 0 and 360. And then the second thing I'm going to do is I'm going to take away 30 degrees from everything. And this gives me 2 theta minus 30 and 330 degrees here. And hopefully you now notice that the thing in the middle of my inequality is exactly the thing that I wanted. These 2 things now match up, which is fantastic. Give myself a big tick. Lucky me. Okay, so what do we do next? Oh, by the way, the order with which you do these matters. It does matter. Okay, if you do it the other way around, if you take away 30 first and then times everything by 2, then the minus 30, when you times it by 2, will become minus 60, and the thing will kind of break. So make sure you get that order correct. Okay, what's next? Angle. The A of our RAMS. Okay, let's do this. So we know that sine of 2 theta minus 30 equals minus 0.6. That's what we had before. So we just do inverse sine of both sides, minus 0.6, and I looked this up earlier. This is minus 36.87. I just did that on my calculator, okay? Remember, this is solution number 1. Brilliant. And I've given this to 2 decimal places just to be safe for now, okay? Give yourself a bit more accuracy than you might need. Next, more. And remember, we need to do this step straight away. As soon as we've done inverse sine, inverse cos, or inverse tan, we need to do the more step straight away. So, how do I find my second angle? Well, hopefully you remember, for sine, I do 180 minus whatever my first angle was. And in this case, this is going to give me 216.87 degrees. Okay? So that's my second solution. What about another solution? Remember, we do number 1 plus 360 degrees. Well, it could be plus or minus, but I'm just going to do plus. And this is going to give me 323.13 degrees. Now that's just in the range. You see this range here? It's just made it. What about a fourth angle? If we maybe do angle number 2 plus 360 degrees, what's that going to give us? Well, that's going to give us, again, I did this on my calculator, and this is going to give me 576.87. Now, again, looking at the range, that's too big, isn't it? So I'm actually, I don't want that one. Okay, and in fact, if we just look here, this initial solution, it's smaller than minus 30, isn't it? So actually this one is no good either. So I've only got two relevant solutions, 216 and 323. Okay, finally, my solution step, solutions. Okay, what do I do here? Well, I know that 2 theta minus 30, that's what these angles are, remember, equals, well, the first one is 216.87. So that means 2 theta equals 246.87, which means that theta equals, let me just do this in my calculator, 246.87 divided by 2, and this will give me 123.4, and I'm going to give that to 1 decimal place. Okay, and let's just do this again for the other solution. So 2 theta minus 30 equals, what was my other solution? 323.13. So 2 theta equals 353.13, and theta equals, well, 353.13 divided by 2 equals 176.6 degrees, again to 1 decimal place, and you should always write that. And look, I've finished. I've got my 2 solutions, and are they in the range that we set? Sorry, not that one, the original range. Are they in the range of the question for my theta? Yes, they absolutely are. And that's us done.